Welcome back. I shan't say ladies and gentlemen. Welcome back to everybody who made it on time. Important thing to talk about. 1 week from today in this very room at this very time, we will have a midterm. Early in the semester, I know surely we're not yet midterm, but we're going to do a test anyway. It's going to include all the material from the very first class to the class right before the midterm, so like it's everything that we've done so far. And your job will be to answer 8 short answer questions. I thought I'd put on that slide, what you're going to do is choose 8 out of 10. So I'll present you 10 short answer questions. You'll select 8 of them to answer. And they're not, so you've got 50 minutes, so whatever 50 minutes divided by 8 is how much time you'll have to answer each of those questions, which I think you'll agree is not a ton of time. So we're not looking for like essay length answers to these questions. Sort of a paragraph is what we're mostly after. Yeah. So here's 4 examples of the type of questions. So I wrote up a bunch of questions and then selected 4 of them to sort of present to you as the sort of questions I'm going to answer or sort of ask you. They mostly start with the word explain. So explain this idea from the course. My goal will be to pick out big important ideas from the course and or important examples that I spent some time on. What I'm going to do to kind of facilitate your studying is post a list of key course terms that I regard as central, important, worth testing on. And then all of the questions will have something to do with one of those key course terms. So, explain what a paradigm is and how it relates to noticing. I think we spent a fair bit of time on that. So a good answer would be something like, so let me just go over what a good answer might look like, and then we'll talk about each of those questions. So good answer is typically going to involve 2 steps, the definition step and then the explanation step. So you're going to start by defining key terms in the question, and then any key terms that you use in your explanation for the answer. Yeah, so like in this one, what a paradigm is and how it relates to noticing. So you'd start with explain what a paradigm is. Explain sort of like a few of the things that we've said about paradigms, and then noticing. I don't know if you have to define noticing. I think that one's not like I didn't define that for you in this class. I just assume you know what noticing is. So explain what a paradigm is. If there's any sort of uncommon terms that you use in defining paradigms, you explain those as well, and then kind of go into the answering the question. So what is a paradigm? How does it relate to noticing? Something like that. I propose to go over answers to these questions I'll go over answers to all of these on Wednesday, if that's okay. So we'll start on Wednesday, think about these, maybe try to write out answers to them, and then I'll go over kind of what I think a really good answer would look like on Wednesday, if that's cool. Yeah? Okay, so good explanation should be such that it would help somebody who hasn't taken the course to understand the issues involved. So these explanations, the job of an explanation is to generate understanding for somebody who doesn't already understand. So your explanation should be such that, if somebody who hadn't taken this course was reading it, they'd go, oh, I got something out of that. I understand this a little bit better. Maybe not like understand it completely end to end, but have some grasp of what you're talking about. So that's kind of the goal. And a good explanation does a few things. We'll talk a little bit about scientific explanation in this course. So we have, there's lots of good theory about what explanations do. One of the things you might want to do with your explanations is unify ideas. So that is put together ideas presented in the course with other ideas. So for example, explain what a paradigm is and how it relates to noticing. You might want to relate a paradigm to, or noticing to the problem of noticing. So we talked about the problem of noticing. This is something that Grinnell talked about. So maybe something good to do here is to say, here's what a paradigm is. Here's how it relates to Grinnell's problem of noticing. That's sort of bringing in another idea from the course, connecting things up. So a good explanation very often hooks up various ideas and shows how they link together. Not just saying that they're connected, but laying out in a sentence or two how they're actually connected. So I think that's one of the things a good explanation does. Yeah? Okay, so I hope that these are not too unexpected kind of questions. Yeah, yeah.
I was just wondering, is it mainly just from lecture? Like, you're not going to ask us anything that was only in the text?
It is mainly from lecture. I think what I'll say is that the questions will be about 80% from lecture, and 1 or 2 of the 10 will be stuff that's exclusively from the readings. The readings up until the test are just the Grinnell, and I think it's maybe 40, 50, 60 pages in total for the reading. So it's not like an hopefully it's not an overwhelming amount of reading, but I will throw in 1 or 2 for those of you who actually did the reading to sort of pick up on. And those will be maybe relatively easy questions to answer if you've done the reading, and very, very difficult to answer if you haven't. So those will be a gift to those of you who did the readings. But again, you're only answering 8 out of 10, so if you're a risk taker and want to just rely on your absolute mastery of the material presented in lecture, then you could just go ahead with that. Up to you, what sort of strategy you want to deal with here. So another question, explain the rat park example and how it relates to the idea of paradigms. So I will pick up on some of the examples we talked about, not just the sort of theoretical terms. So just roughly what happened in that, and then I tried to connect it to the idea of paradigms, the idea of noticing last time. Explain Zizek's notion of ideology, how it relates to science, or explain Plato's paradox of discovery and how Grinnell thinks it can be solved. I hope none of that's wildly unexpected. If you've been coming to class, if you've been doing the readings, I hope you're at least familiar with these ideas. So I'm not going to pick up on the tiniest little details of the course. My goal is to make them big ideas from the course, and then your job is just to sort of show me that you get them. So demonstrate your understanding, demonstrate to me that you've been listening and processing and maybe thinking a little, and able to connect up the different parts of the course. Yeah? Okay, so I'm not going to ask you any, like, tell me your thesis on this, so there's not going to be any kind of, on the test, I'm really just testing your understanding of the material, not like, do you have an elaborate theory about this? That's more, we'll get more into that when we do the essays. The essays will be more like, show me the critical thinking that you're capable of. Here, it's really just, show me that you've been listening and attending and that kind of thing. Yeah? Okay, questions about this? And we can certainly discuss it more on Wednesday. Okay with this? Okay, good. Okay, so we'll do a little bit of review and we'll dive into new stuff. So we've been talking about this half of Grinnell's model of science, the discovery half. Today we're going to start in on the credibility half, although these things sort of bleed into each other, don't they? There's not a very crisp separation between the two, because the things that the scientist finds credible are the things in their paradigm, and the things in their paradigm influence the way that they come to the world and notice things in it. So these aren't like radically separate processes, they feed into each other in a deep way. We talked a lot about the problem of noticing, the problem of being able to pick out the relevant details from all of the myriad possible things that you could be noticing. The central points that I was trying to make, and I would like to go over this a little bit just so that I think it was slightly confusing what points I was trying to make with which examples, so that's what I would like to at least briefly go over. So the insight problem solving stuff was meant to show you that the problem of noticing is not just a scientific problem, it's a general cognitive problem. For any being that's capable of noticing, like, you have the capacity to notice more things than you've got the time and energy to notice. So that means that you have to be selective, you have to pick and choose what you're going to notice, and that's just a fact about us, that we've got way more available to us than we could possibly process, and sometimes the way that you've decided to notice things is frustrating your efforts at solving your problems rather than facilitating it. In science, that's temporarily dealt with. It's dealt with on a day-to-day basis by having a paradigm, by having some set of beliefs and assumptions, a set of sort of like background assumptions about what counts as a good experiment, what observations are relevant, that kind of thing. That's what a paradigm is those assumptions and beliefs that you bring to bear on the world to help you interpret it. But of course, paradigms can restrict what you notice as well as enabling notice. In some sense, by restricting your capacity to notice things, they help you notice better. That's it sounds paradoxical, but I don't think it is. I think very often we enable people by restricting them. So for example, somebody imposed literacy on you. Somebody decided that you were going to learn to read. And I hope you feel that that restriction on your early life choices, like if you as a toddler said, I don't feel like learning to read, people were like, well, I don't care what you think, you're going to do it anyway. So hopefully that restriction you feel enables you later in life to have more freedom. Similarly, paradigms restrict what you can notice, but at the same time, they enable us to notice better, because then you've got at least some framework in which to notice things. But ideology, so a paradigm is a scientific set of assumptions, beliefs, judgments about what's important or relevant. We've also got much broader ones about what counts as a good life, what's acceptable behavior, how should we organize ourselves socially, politically, that kind of thing. And we might call that ideology. So, ideology is a sort of unconscious values that structure the way that we go about our lives. And last time we talked about a few ways in which ideology can very seriously distort science. So it's the problem here is that everybody's got an ideology. We don't ever come to the world ideology free, like because there's way too much of the universe to deal with. You can't just not have assumptions about it. You can't just not have background beliefs. So I'm not saying we should, in some sense, get rid of ideology or that the good science is ideology free. The argument was more that what we need to be is sensitive to the fact that we've got these assumptions, we've got these background beliefs, and that they can potentially cause problems for us. And furthermore, it can make, your ideology can make it seem as though something which you might think it's a scientific fact, but actually it's some mashup of science and values together that's sort of being presented to you. So just to go through the kind of examples, so we talked about Rat Park as an example of somebody resisting the paradigm that they were in. So there was this paradigm that says, here's the thing that matters. When we're thinking about, for example, the behavior of mammals, specifically with respect to addiction, what matters is behavior with respect to being dosed with a drug. And it didn't matter what environment that was happening in. So the social environment or the kind of like aesthetic qualities of the environment were regarded as irrelevant. In fact, they were kind of screened off, right? They say, we're gonna strip away all of the complexity of social aesthetic environments and just look at the pure relationship between substance and behavior. And so that was a kind of choice about what's important to test, what's important to notice. That's built into the kind of behaviorist paradigm. And then the Rat Park experiment opened that up and said, actually, what if we do include these questions? What if we consider as a mitigating factor in the relationship between substances and behavior, things like, does this rat have a social life? Does this rat have the ability to move around or do stuff, play, hide, fight, that kind of thing? So this was a shift in the assumptions about what's relevant, and it produced some interesting results. We talked about insight problems. This was supposed to be the argument that this stuff is ubiquitous. That is, noticing is not just a scientific problem, it's a general cognitive problem. We talked a little bit about Zizek's definition of ideology, which is supposed to be this stuff about kind of our broader set of assumptions that we bring to bear on the world. We had this definition of ideology, things that you know that you don't know that you know. This was his definition. Yeah? So the beliefs and assumptions that you bring to bear on the world, in that sense, know, but you're not aware of in the sense of having them as an object of knowledge. And we talked about some ways in which ideology can, this is one of the worst case scenarios for ideology playing a role in science. Like the Lysenkoism affair was supposed to be an example of how this can radically distort and interfere with good science, because here views about human nature, that is, that we are more a product of our environment than of our sort of genetic dispositions, was taken as such an object of faith. It was sort of an evidence-free object of faith that they were willing to throw out the best available science at the time, which was Mendelian genetics, in favor of Lysenko's attempts to do vernalization, sort of iterated vernalization, such that the environment would tell the the spring crops to become winter crops. No, winter crops to become spring crops. Yeah, so the belief in the larger Soviet society at the time that environment is the only thing that matters sort of steamrolled over the best available evidence. Yeah, so this is supposed to be an example of broader social cultural beliefs being sort of imported into science. So that's the sort of ideology distorting the science part. And then we did an example that goes kind of in the opposite direction. So I'd like to distinguish these two examples and what I hope that they would show. The Lysenkoism one was supposed to be broader social ideologies distorting science. This is supposed to be where a bit of scientific knowledge is taken to be confirmatory for your ideological belief. So in some sense, this is science feeding the ideology. The social Darwinism movement, I mean, again, they didn't call themselves that, it was a sort of term of derision, but the idea that Darwinian theory proves that you should be allowed to be as brutal and tyrannical to anybody you can dominate as you want was a sort of, you're seeing your worldview in the science as though your values are being fed to you from the world directly. Yeah? So this is the science in some sense adding fuel to the social political beliefs rather than the social political beliefs being distorting the science. So it's in some sense going the opposite direction, but it's supposed to be just another example of the way that science and ideology can interact in potentially harmful ways. Yeah? Okay, so that's what we did last time. Any questions or concerns about any of that stuff? Okay, good. Oh, yeah.
What I find funny about the social Darwinism kind of thing
Yeah.
is definitely still in play nowadays.
Right. Yeah. So it's not hard to find people who still think. So social Darwinism, the term usually refers to the kind of colonialist period, but there are absolutely still people running around who believe that Darwinian theory justifies them in doing basically whatever they want to whomever they want on the thought that it's the strongest, the strong will survive. Yeah, there are definitely still people like this around. And they've just committed what we call the naturalistic fallacy, right? That is the belief that if something is natural, then it's good. I mean, there's lots of things, surely you can think of lots of things that are in nature that we don't want to, like, I used the example of cyanide last time. Chimpanzees will sometimes, so male chimpanzees will sometimes kill and eat the offspring of somebody they want to mate with. So they take a new mate who's had children with another male previously. They will kill and eat the offspring of that previous mate so that the mother has more resources to raise their child. Now, very natural, but I hope that infant murder and cannibalism doesn't strike you as justified by that little anecdote, right? That's nothing in that story, and there's perfectly good Darwinian reasons why they do that, right? So this other offspring has somebody else's genes, they want resources to go to somebody with their genes. That doesn't make infant cannibalism a good idea, right?
It's kind of a dick move.
It's I mean, that might be understating it for how bad infant cannibalism is. Yeah, so just because it's natural doesn't mean it's a good idea. It doesn't mean that we should just roll with whatever happens to be existing in the natural world. We also talked a little bit about the different interpretations of this. We talked about the eugenics sort of interpretation, which is that they thought, like, look at all these rich people who are clearly the better people. Again, that's the ideology part, that rich people are better. They're not having as many children as the poor people. Therefore, we need to intervene in this system to change the birth rates. That's just kind of even throwing out the Darwinian theory. According to Darwinian theory, whoever is reproducing the most is more fit. And fitness is not a moral standing, it's a kind of biological trait. And we saw Alfred Russel Wallace, one of the co-inventors of the Darwinian theory, say just the exact opposite in terms of policy. So he says things like, we should abolish inheritance because that's distorting natural selection. We should expect that cooperation will take over the world because cooperative groups are more effective. So in intergroup competition, cooperation will take over instead of ruthless competition. So people can kind of see, the point of this was, if you're not sensitive to the ways that ideology and science are interacting, people can easily see whatever their worldview is in the science. And it's not in the science, it's an interaction between the two. That was the point of this example. Yeah.
This is slightly different, but Darwinism and evolution was kind of incorporated into economics and business theory, where the way that they analyze how companies compete against each other is that they treat the company as though it's an organism.
Yeah.
And
yeah.
so when if you have two companies competing in a market and one drives the other one out of business, it's like an extinction event.
Right. So Darwinism has been applied very widely, and it's unclear how widely it makes sense to apply it. So it's been applied to social and cultural evolution as well. So business is one example of things that might theoretically evolve. Richard Dawkins famously applied it to ideas in his memetics notion. So Dawkins comes up with the idea of a meme, which in his original sense was just like a bit of culture that is likely to reproduce itself, something like that. So unclear how far it should apply, but that's a kind of scientific question. Okay, good. So we've done the overall, we've done the discovery cycle. Let's now talk more directly about credibility. So that's what we'll do this week, the kind of credibility cycle where once an individual scientist has made a discovery claim, how does it get A, disseminated, and B, how does the broader research community decide that that was actually a good idea? So Grinnell wants to make this distinction between science and proto-science. He thinks a discovery claim, just once an individual scientist or a small group of scientists has produced some claim, that's not yet a scientific fact for him. He wants to call that proto-science. It's really only after it's made it through the credibility cycle that he wants to call something scientific knowledge. He says, and here's why. Here's a quote from the readings. No matter how diligently researchers try to be unbiased about their work, they cannot escape the potential for misinterpretation, error, and self-deception. Consequently, we should think of new discoveries initially as proto-science, discovery claims. It's a pretty grim assessment. The idea that we can't escape as individuals the potential for self-deception, misinterpretation, and error. Yeah? So this is why he thinks that before it's gone through the credibility process, we can't help but be in danger of being biased. Now this rests on the idea that individuals, as individuals, can't escape the danger of bias. And I think that this is actually very well supported by a lot of 20th century psychology and 21st century psychology as well. So one of the major discoveries of the kind of 21st century cognitive psychology was that we are riddled with cognitive biases, like that all of us make kind of systematic errors in the way that we reason, and that basically none of us are immune from this. You can find these biases in people who are specifically trained in the techniques of sort of ideal reasoning, ideal rationality. It doesn't, just having training, for example, in math or logic or philosophy does not kind of make you not have these biases anymore. So we've all basically got them built in. Just as a couple of examples, I think ones that are particularly relevant to science, confirmation bias. So here's a fact about us. People are much more likely to regard as important or interesting or notice information that supports their opinion rather than information that doesn't support their opinion. So if you see something that sort of fits into the way you're thinking about things, it will leap out at you. It will shine brightly. It will sort of seem really important. Whereas if you see something that disconfirms your views, it's not like it's invisible to you, but you'll put substantially less weight on it. And if we were ideally rational, you would expect those things to be perfectly balanced, wouldn't you? Right? The importance of confirmatory and disconfirmatory evidence should be pretty much the same, right? right? But as a matter of fact, people on average tend to pay more attention to confirmatory evidence. Yeah?
If you don't mind me pointing out, I wanted to also say, like, in terms of science, yeah, bias is not that great, but you also have to remember evolutionarily,
Right.
bias is pretty important.
Right,
in a
yes.
way for us to just have survived as
Good.
a species.
Good, yeah. I think that's absolutely right. So I wasn't going to dip into this, but I think that's absolutely right. So there's a way of explaining the biases that we have. I called the fire detector effect, which is as follows. There are some errors which are very cheap and some errors which are very expensive. So your fire detector, for example, doesn't always know when there's a fire, right? It gets it wrong a lot of the time. But one type of error, a false positive, where it says, oh no, there's a fire, and it turns out it's just you're making toast. That's a very cheap error, right? You open the window, you swing a pillow at it, the end. A false negative, where there is a fire, but your fire detector doesn't go off, is a very costly error. You and your family die in a fire, right? So what you want is a fire detector that's heavily biased towards one type of error, right? One type of error is much cheaper and easier to deal with than the other type of error. So the theory about cognitive biases is precisely that we're like this. So we're biased towards making errors that are cheap and easy to deal with. So if it was the case that every little bit of disconfirming evidence for your theories sort of crush your confidence in your theories, probably you're going to be less effective in the world. Probably you're going to get less done. And I take this as evidence that evolution seems to have shaped us to be boldly overconfident in most cases. People also have biases, so the whole class of optimistic biases, like a large majority of people consider themselves better than average drivers. Something to keep in mind if you're out on the roads. But what do you know? You know for certain that half of people are better than average drivers and no more, right? But a large majority of us think that we are. We seem to be programmed to be kind of over-optimistic, to shield ourselves from negative influence, negative sort of reinforcement and that kind of thing. Probably because you're more effective in the world if you act like that. Like if you act super confident, you're more likely to get stuff done. It's true. Many of these biases go away, for example, so these are just averages in the population. Many of them go away in depressed people. So if you're very depressed, all those optimistic biases go away. But then you're depressed, and it's bad. It's a suboptimal way to live, I assure you. So yeah. So there might be good reasons why we're built this way, I guess is the point. So thank you, that's a very good note. There's probably good reasons why we're set up this way, because evolution doesn't really care whether you have the truth in your head, it cares whether you are succeeding in your life projects. That's basically all it's tracking. So here's another one. Errors in probabilistic reasoning. So this is a classic example of a kind of cognitive bias. So people are given the following story and then asked about Linda. So Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Okay, so there's a little biography of Linda, and then people were asked the following question about her. Is it more likely that she is A, a bank teller, or B, a feminist and a bank teller? And people mostly answer, two, not B. People mostly answer two. But according to probability theory, it is impossible for the conjunction of two things to be more likely than one of the disjuncts. So this feminist and a bank teller cannot possibly be more likely than just being a bank teller. Yeah, that's just a fact about like so there's two probabilities here. The probability she's a feminist, the probability she's a bank teller. The probability that she's both is this times this, which is always smaller than just being a bank teller. So this is a kind of systematic. Did that jump out at you? Like, oh yeah, she's probably a feminist and a bank teller. Did anybody immediately go to, no, the probability of two disjuncts is always low. Did that go through anybody's head? Yeah, you're okay. Have you
Because I've seen this.
Okay, good,
But
good.
Isn't that kind of creating an oversimplified model? Like if you're just looking at the pure probabilities, you're ignoring all the other data.
That's right.
That would imply.
That's right. So what people are doing is being really good at meaningfully integrating information, which if you're trying to succeed in your life projects, that's a crucially important skill, right? You want to be, so you've been given a whole bunch of biography about Linda, and what your brain wants to do is use it. Use the information that you have available, bring it together into a meaningful whole. It apparently cares more about that than the strict dictates of probability theory, which again is probably a good survival strategy. It's probably a good strategy in general, given that we don't have time and energy to like compute the probabilities of things. In general, you're not going around and computing the probabilities of things. You're just trying to put your world, it's much more important that you put your world together into meaningful wholes than figure out, strict probabilities. But nonetheless, this is a deviation between, it's still a deviation between ideal rationality, like ideal rationality of probability theory. And once I said this, I hope it was fairly clear. The probability of two things put together is always less than the probability of just one of them, right? So if we're doing kind of ideal rationality, number one is the better answer than number two. So so here's a couple of examples of cognitive biases. One last one, we'll leave off on this. People tend to overestimate the strength of arguments when they believe the conclusion, called belief bias. So if I present this argument to you, all actors are vain, Tom Cruise is vain, therefore Tom Cruise is an actor. People, if you believe those premises and you believe that conclusion, people are much more likely to think, that sounds like a good argument to me. But that argument is a fallacy. It's a formal fallacy. It's a classic error in reasoning. So if I say all dogs are mammals and Fluffy is a mammal, therefore Fluffy is a dog. Or how about this? All dogs are mammals, Corey is a mammal, therefore Corey is a dog. That argument doesn't work, right? That's affirming the consequent. It's a bad argument. So you don't believe the conclusion of that argument. Presumably you think I'm a Homo sapien. So you're like, now I can see that that's a bad argument. But the quality of the argument actually doesn't, so the logical strength of the argument doesn't depend on the truth or falsity of any of its parts. So people are, when you believe the conclusion, you are more likely to think the argument for that conclusion was good, which is why people very often think about this in political discussion. People will tolerate very shoddy arguments for views that they agree with. Their opponents aren't going to tolerate the shoddy arguments. The opponents of your beliefs will be very happy to point out why that's a bad argument, because they're not subject to belief bias in the same way. Well, they're not about that conclusion, right? So these are all things that have sort of come up again and again. These are very well validated. I mean, of the results of psychology, these are some of the ones that I'm kind of willing to bet are going to be robust for long term. People seem to be deeply subject to cognitive biases. Yeah. And we think about, for example, confirmation bias. You're trying to do a scientific study. You are like the people that discovered the DNA, RNA, protein relationship. You are fully convinced of your hypothesis. You are deeply convicted that you got the right answer. And you kind of have to be able to deal with the challenges of doing science, right? Like it's not a game for people who are easily dissuaded or easily sort of put off. So you're fully convinced that your hypothesis is true. And you see some confirming evidence. You go, aha, I knew it all along. And you see some disconfirming evidence. You say, maybe we set up the experiment wrong. Yeah? And that's not people being dishonest. This is people doing their level best, their honest best, using the equipment that we all share to try to evaluate the evidence. Nonetheless, they're going to be subject to this style of bias. So I think this is why Grinnell says about discovery claims that we should call them proto-science rather than science, because a discovery claim is built up under these conditions. The conditions of all humans have got these things in us. Comprehensively, we should probably be glad we have them in us because it makes us able to live in a very hostile and confusing world and sometimes be successful in our projects. So I'm not saying we should try to get rid of these things, but we should be wary of them when we're trying to evaluate something that was produced by just one individual. So one way of thinking about the scientific process, the scientific method broadly construed, is as a way of coping with this fact about ourselves. It's a way of trying to mitigate the damage that could potentially be inflicted by the fact that we're all riddled with cognitive biases. So what we do is take proto-scientific discovery claims and put them through the credibility process in order to try to test whether this is the result of the biases of individuals, of motivated reasoning, confirmation bias, belief bias, that kind of thing. And it can kind of help overcome what we might call the subjectivity of discovery. So that's the whole point of the credibility process. And that's why you can't think of science, I think it's a deep mistake to think of science as something done by individuals rather than communities. It's communities that enact this credibility process, and it's the fact that it's a bunch of people talking to each other that makes it possible to do things like overcome confirmation bias, because you deeply believe your hypothesis, somebody else probably doesn't as much, so they're not subject to the same degree of bias as you are. Or you might have conflicting biases, and you kind of bounce them off each other. So, Grinnell starts at this point talking about intersubjectivity. So we might distinguish a few things here. So something is subjective if it's maybe particular to one individual. So I have thoughts and feelings about oatmeal with raisins in it. Those thoughts and feelings are mine. There's no reasonable expectation that anybody else would share them. I don't have to justify them. I don't have to expect that they're features of reality. We might also talk about a couple of types of objectivity. We talked about this before. So like objectivity 1, let's call it. Something is not from any point of view at all, right? It's not tied to a subjective point of view. And we'd better hope that that's not the goal, because nobody's ever thought or seen anything that wasn't from a point of view. Everything that you ever experience has to come from some point of view or other. That seems to be just I don't know any way of disputing that. It seems like if you just understand how words work, I think you should agree with that one. Objectivity 2, maybe we could talk a little bit. I mean, this is potentially a real thing. Something might be value neutral, right? So not from any values point of view, not from an ideological point of view, or something like that. But nobody's value neutral in the sense of not having any values, right? And of course, there are shared values amongst everybody. So some things you might hope that everybody shares values about, like human life is precious and should be respected, or something like that. So we might want to give up on talking about objectivity in general, or we might want to shift to talking about what he calls intersubjectivity. Intersubjectivity, that is, things shared amongst perspectives. So when we're thinking about something like math, for example, everybody learns math through their human psychology. They learn it through their senses, which are fallible. You might not, you might think that it's a questionable thing, but what's true about 2 + 2 = 4 is that it's shared amongst everybody. Everybody who's competent with math agrees on that. So you might agree or disagree about whether it's actually a big debate in philosophy of math, whether it's a fact about the universe or a human construction. The part that we can agree on is that the basics of arithmetic are shared amongst anybody who does them. And the history of math bears that so profoundly. Like the Pythagorean theorem was independently discovered in 4 different civilizations. Completely historically separate people came up with the same Pythagorean theorem. And so it doesn't seem to depend on your culture or values or worldview. People with very different cultures, very different values and worldviews all came up with the same thing. So intersubjectivity is not being outside of culture. It's not being outside of a perspective or a way of conceptualizing or anything like that. What it is being shared amongst perspectives. And that's maybe as good as we can get. That might be the goal. It might be a reasonable goal to pursue. Intersubjectivity. Yeah? Okay. Okay, so once again, I've prepared too much for this lecture, but we'll get as far as we can. Here's a kind of more, so on the original slide, it was just a big loop. Here's a little bit more detailed map from Grinnell about the credibility process. So we've talked about each of these steps already. You know, you've got some individual researcher, research group interacting with the world in some sense. They're generating things like research notebooks. They're generating things like spreadsheets and whiteboards covered in notes and stuff like that. Once they have a discovery claim, they send it off to some journal where it goes to editors and reviewers. If it makes it past that stage, they get it published. And if it gets published, then if it's a good one, or if it's one that people find credible, they will cite it and sort of use it going forward as the basis for doing further science. And then there's this even further sort of depth into the credibility process. So scientists have agreed that it's reasonable. They've started citing it. They've started using it as the basis for doing further science. If it gets really far into that process, then it might make it into a textbook. Then it might make it into sort of like the education of young people. It gets into the popular culture, that kind of thing. So other scientists and all the way to the public, and then sort of feeding back into the scientific process. Okay, so hopefully this stuff is familiar to you guys, but like just briefly the peer review process, like you write up a manuscript. It's this cleaned up version, as we've talked about, of the actual discovery process where you pretend that you knew all along what you were doing. And then you send it to a scientific journal. Editors will read it to see if it's it's maybe worth publishing. So scientific journals get a fair degree of random crackpottery, stuff that just doesn't resemble science at all, people who have no scientific credibility and who have not done anything serious. So they do what they call desk rejection. They say, like, look, I'm not even going to find people to review this. Just take this elsewhere, please. Or if it's just not appropriate for the journal, so journals have specialization. So you say, like, look, this looks fine. It's just not what we do here. I suggest you take it to some other journal. So if it gets past that, what they do is recruit 2 or 3 external reviewers. That is hopefully people who are specialists in that field. And then they sort of take everybody's names off the manuscript. So they've got the submitted journal article. They take the names off it. So typically they do blind review, and hopefully double blind review, where the people who submitted the journal article don't know who the reviewers are, and the reviewers don't know who wrote the thing. This is to try to take away the idea that, you know, more famous or more, you know, you don't want to, if somebody's like, you know, got social cachet or something like that, or maybe somebody who was a jerk to you at a conference and they submit a paper and you're the reviewer for it and you say, aha, now I've got you. You just reject it right away. That's meant to kind of filter that kind of stuff out. It's an imperfect system because very often scientists are working in extremely specific subfields where there's like a dozen people who actually are doing work on it. And the chances of the reviewers being able to figure out who wrote the paper are pretty high. If the reviewer is motivated to do so, it's not super difficult to Google the key terms in the paper and work out who wrote it. Or if they've been talking, if they're part of the scientific community, which of course they are, they might have even talked to you at a conference about the paper. They might have seen it. So before submitting to a journal, it's very common to present a paper at a conference. And in a small scientific community, most of the major people are at the conference or heard about the conference. So the blinding process is imperfect at best, but that's their attempt at trying to make that part of this fair. And then the reviewers sort of read the thing and say either that it's good, go ahead and publish it. More common is to either reject it, say no, this isn't good enough, or revise and resubmit, which is to say, if you make these changes, sometimes up to, like, it can be as small as rewriting a section or as big as you need to reanalyze your data, so redo major parts of the research program, then we'll consider this a credible paper, and then it gets published. Or not, I mean, yeah. Okay, so when targeting their, I don't know how much of this is news to you, but for the people who do sciences, keep in mind there's a mix of people from humanities and sciences in this room. So the humanities people might not have might not be well familiar with this stuff. When you're targeting a paper, you try to get, you've got a paper, so you and your team have come up with some discovery claim, it's Proto-Science, you're trying to get it out there. What you want to do is publish it in the most prestigious journal that you can. So to get the most visibility, and we talked about sort of gaining credibility as a scientist, the more high ranked the journal is that you can get it into, the more kind of credibility you accrue. So you're always aiming to get it into the most prestigious journal that you can. The problem is prestige is hard to quantify. There are a bunch of different metrics that people use for this. Impact factor is one of the big ones. So the impact factor of a journal is a measure of how many times the average publication in that journal is cited by somebody else. So the real kind of like special sauce of being a credible scientist is writing things that other people use in their science. So having cited somebody is to say, this was part of my process for doing a further study or something like that. So when a journal is cited very often, and the top journals are cited like average paper cited dozens or 40, 50 times or something like that, that means those journals are making a big impact on the discussion. So credibility as a scientist comes from having made an impact on the discussion. And the more prestigious the journal you can get your paper into, the more impact it's going to make. So this kind of like feedback cycle of prestige and credibility.